Now let us understand the very important concept of relating difference quotient with slope of tangent line at any point on the curve. With the simple example will illustrate how this difference quotient represents the slope of tangent line. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we will extend the difference quotient concept and see how does it relate to define slope of a tangent line at any point on a curve. This is a very important concept on calculus and it is the foundation for understanding derivatives. So basically, we are going to relate difference quotient to derivatives of functions. For doing so, I have taken a very simple example. With this example, I hope the concepts will be absolutely clear. You can then do more examples to master the technique. The question here is, let the displacement in meters that a toy car travels after t minutes be given by d of t equals to 3t squared for t greater than equal to 0, less than equal to c. Graph of d of t is given to you. Questions, 4 of them related to this equation are: simplify d of t plus h minus dt over h for difference quotient of d of t. Interpret its significance. So we did a similar question earlier where we related difference quotient with gradient, right? So it is an extension where we are going to relate this to derivatives. Question 2. Evaluate the difference quotient for t equals to 2 and h equals to 1, 0.1, 0.01, 0.001. Interpret your result, represent your result on the graph. So this is where we will see how slope of a secant line approaches the slope of a tangent line. So we have taken a point 2, t equals to 2, and h is slightly away from t, and that is 0.1, 0.01, 0.001 away from t. Question number 3. Limit h approaches 0 for this difference quotient expression, which is d of t plus h minus d of t over h, represents the slope of tangent at any point on d of t. So once we do this exercise in question 2, we'll understand question 3, how the gradient now represents the gradient of a tangent when h approaches 0. And question number 4 is, find equation of the tangent line at 2, 12. Interpret your result, represent your result on the graph. So with that, you will get a complete concept of starting from finding the gradient to understanding the definition of tangent line, and then finding equation of tangent line. So I hope this concept is absolutely clear. Let's begin with the very first question now, which is, we need to simplify the given expression for difference quotient. The expression is d of t plus h minus d of t over h. Now, we are also given the function, which is d of t is 3t squared. So what will be d of t plus h? We'll replace t with 3t squared, with t plus h, right, in 3t squared, correct? So we could write this as equal to d of t plus h basically will be the function dt is 3t squared. So we'll write 3, and instead of t, we'll write t plus h, correct? Whole square minus d of t is 3t squared. Is that clear to you? Over h. Perfect. So we wrote this since we are given that d of t is basically equal to 3t squared. Is that okay? So t plus h will be replace t with t plus h. Perfect. So this can be written as, let us expand this, 3 times t square plus 2th plus h square minus 3t square over h, right? So you will notice that this 3t square and 3t square cancel, and we can now simplify the expression as, open the bracket, 3 times 2 is 6th plus h square over h. Now h is common in the numerator, so we can write down this as t, 6t, let me write down, right? 6 is the coefficient, so we have 6t plus h over h, right? Now we can cancel h and h from the numerator and denominator and get the final expression, which is 6t plus h. So that becomes so now let us begin with answering these questions and understanding the concept. Question number 1. Let the displacement in meters that a toy car travels after t minutes be given by d of t equals to 3t squared for t between 0 to 6. Graph of d of t is given to you, right? So this is for the function d of t, which is equal to 3t squared. Question 1 is, simplify this expression, which is called difference quotient expression. Let me rewrite this. It is d of t plus h minus d of t over h for difference quotient of d of t. So when I say d of t plus h, basically in the function, we replace t with t plus h. So what we get is 3 times t plus h whole square minus 3t square, right, over h. Now let's expand t plus h whole square. So we get 3 times t square plus 2th plus h square minus 3t square over h, correct? So 3t square and 3t square will cancel. So we'll cancel 3t square and 3t square. And we get this expression as 3 times 2, 6, right? th plus h square, 3h square, right? Over h. Now let us simplify it by taking h common from the numerator terms. So we get h 6t plus 3h, right? And in denominator we have h. So they cancel. Now that gives us the simplified expression, which is 6t plus 3h. So the difference quotient, which is d t plus h minus dt, can be written as 6t plus 3h when d of t is 3t squared, correct? That's what it means. Now, part 2 is to interpret its significance. Now, how do we interpret the significance of this function? Let's look into this. So, difference quotient, as you know, gives you the gradient of a secant or a chord between 2 points. So, we could see it as a slope of a chord from point A to point B, where A is at any point t and B is at t plus h. So after h minutes, you see that? Now, from here you can see that the delta y, the difference in y values, is actually what? Is f of t plus h minus f of t, right? Which is the numerator. And here we have t plus h minus t, which is h. You see that? So this is slope of secant. From t to t plus h. Is that clear to you? So that is what it represents. Perfect. Now let's move on and take the next example. Remember, we got the expression for difference quotient given dt as 3t squared as 6t plus 3h.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshit gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. The question here is, evaluate the difference quotient for t equals to 2 and h equals to 4 different values, starting with 1 to 0.1, 0.01, 0.001. Interpret your result, represent your result on the graph. So now, we were given the function d of t, which was 3t squared, and we just found that d of t plus h minus d of t over h is equal to 6t plus 3h, right? That's what we found in answer for question number 1. Now let's continue from here. We'll use this particular simplified expression to find the difference quotient at different values of t and h, right? So let's make a table for this. So I will calculate the value for t equals to, we'll have different values of t and h, right? Let me just make a table here. So let's take value of t and h and we'll calculate what is 6t plus 3h. Make sense? For different values of this t, right? Let us extend. Okay, that makes sense. So for t equals to 2, so in each case, t is 2, a constant value, h is 1. So if I write 2 here, I get 6 times 2 plus 3 times 1. And what we get here is, let me extend this, as equal to 12 plus 3, 15, correct? We get 15, right? Okay, now let's take another value. I'm changing the ink. If I take t as 2 and h as 0.1, I get 6 times 2 plus 3 times 0.1. So it becomes what? 6 times 2 is 12 and 0.3. So we get 12.3. Do you see that? And if I take value of h, which is even lesser, 0.01, I get 6 times 2 plus 3 times 0.01, and that gives me 12.03, right? And if I take a value which is 0.001, I get 6 times 2 plus 3 times 0.001. That gives me 12.003. Do you see that? So what do you notice? You notice that the difference quotient value, which we are calculating, is approaching 12. Do you see that? As h approaching a smaller value, right? So as h approaches, let us say 0, in that case, the difference quotient, which is the slope of secant line, is approaching 12 in this case. You get an idea. Is approaching 12 in this case. So what is happening here is that the secant is becoming a tangent, and that becomes the slope of the tangent. Now let me, as a part of this question, represent your result on the graph. Let me also show you this on the graph, right? So what I'm trying to say here is that the secant is becoming slope of the tangent, right? So let me just show it on the graph. So what we notice basically that as we are figuring out the slope between 2 points, t equals to 2, and h value being at starting with 1 means 1 unit away. So let me make it wider, right? So that I could explain it better. So what really happened, this was a secant line. As I brought this point closer and closer, it actually became kind of like this, a tangent. Do you see that? So the secant approaches tangent. Correct? So let me make it bigger to explain the whole concept. So what really is happening is that, so I'm just expanding this particular part here, right? So the graph is kind of like this. So we have taken a point t as 2, which is fixed, right? And h as 1 to begin with. Let's say h is here. So this is at t as 2, and this is h as 1 means 3, correct? Then we came closer to this. So the next graph was kind of here, right? And then we came even closer. And finally, we have a graph which is kind of like this. Do you see that? So what is happening here is that the secant, which is from A to B, turns out to be a tangent at A as h approaches very small value. We say h approaches 0. And we call this as slope of tangent. And in our case, this is equal to 12, right? Because we approached a value which is 12. Do you see that? So it changes from 15 to 12, right? So we are approaching 12. So m is equal to 12 at t equals to 2. Makes sense? That is what it means. Perfect. So I hope this explanation is clear to you. So basically, we are saying that this particular expression, which is d of t plus h minus d of t over h, for the given function 6t squared is 6t plus 3h. It approaches 6t. Since t is 2, 6 times 2 is 12. You get the idea, right? So at t equals to 2, this will be 6 times 2, which is 12, as calculated earlier. Perfect. Now let's move on to question number 3, which is, let the displacement, the same question, and limit, now we have written here limit h approaches 0 for d of t plus h minus d of t over h. represent the slope of tangent at any point on the curve d of t, right? That is the explanation, right? So basically what we are saying now is that what I explained earlier, that the function d of t, which is equal to 3t squared, right? In that case, this is the tangent at a particular point t, right? That is the tangent. So we get this as slope of the tangent when h approaches 0. You get the idea. H approaches 0 means earlier we were working with a secant kind of like this. So as we came closer and closer, this became tangent. Perfect. That's what it means. Now, once you have understood this concept that difference quotient can be treated as a tangent when h approaches 0, we can actually find the equation of tangent line. So question number 4 is find the equation of tangent at 212. So we are given the function which is d of t equals to 3t squared. So d of 2, you know, will be what? 3 times 2 square, right? Which is 12. So the point is on the graph, right? So on the graph, just as we were trying to sketch, right? Let me just sketch it once again. Because our graph is limited from 0 to 6. So we have this particular tangent, this value at 2, right? And the y value here is 12. So at this point, we have to find equation of this tangent line. So this line is tangent, correct? We have to find this equation. So since the slope is equal to, which we found as 6 times t, right? Which was 6 times 2 or 12. And the point is 212. So the equation of tangent will be what? We can write the equation as y minus y1 equals to m times x minus x1. So in this case, y minus y1 is 12 equals to the slope of 12 x minus 2, correct? So that becomes the equation. So y equals to, we can take this 12 on the right hand side. We get 12x minus 24 plus 12, which is 12x minus 12. Is it okay? So that becomes the slope of the equation of the tangent line at 2. Perfect. So that is how we are going to answer this particular question. Perfect. So I hope the concept is absolutely clear, right? So here is the graph. So if I draw a slope at this particular point, a tangent, then it will have kind of like this, right? Where the slope m is equals to 12, the point which we are considering is 212, correct? And the equation of this line, y equals to 12x minus 12. Perfect. So I hope you have understood the whole concept. So the difference quotient represents slope of a tangent line m when the limit of h approaches 0, right? So we get t plus h minus d of t over h. For any function, we can adopt this method of finding slope of a tangent line. Perfect. So I hope with this, you've understood the concept. Now in this playlist, we'll have many other questions for you. In case you like and subscribe to my videos, it'd be great. Feel free to write your comments and suggestions. And if you want to learn from me, you can always send an email on the address given. Thanks for your time and all the best.